Alright, let's do some basic finance stuff here. So we're looking at simple and compound interest and comparing the two of those together. So the two formulas we had: simple interest is just principal times rate times time. Compound interest, where the amount earned is principal times 1 plus the rate raised to t power, where t is time, r is rate, principal, all that. Okay, so the problem we're looking at, number 12, I just picked out one because if you can do one, you can do all of them. It says a deposit of $10,000, so that becomes our principal. And let's actually change this to money up here. Okay, $10,000. Our rate is 6%, and I already changed that to percent, so that's good. And our time is 5 years. Okay. So the first thing we want to find is simple interest, because that's the easiest. Interest. So all that is the three numbers multiplied together. So to put that in Excel, or anything else that'll do equations for you, we're going to put equals, and then it's just principal times rate times time. That's it. Hit enter. $3,000 interest. And what's nice about Excel is it recognizes, hey, this is a percent, and it changes it to a decimal for you. So this is our correct answer. Okay. And let's say we wanted to find the new balance with simple interest. And let's see. Make this look a little bit nicer here. Oops, too far. So the new balance would be equal to the original balance plus the interest we earned. So after 5 years, $10,000 plus $3,000 more would give us $13,000. Okay, that's simple interest. So a little bit more complicated is compound interest. And that formula is going to look just like this. This one here. Whoops. So equals a principal times, and then in parentheses, because the parentheses matters here, 1 plus the rate, okay, close parentheses, caret, which shows exponent, which is shift 6 on your keyboard, okay, times the time, or not times, but raised to that power, and then that's it. That's our whole formula. We hit enter. So what this one does, and I guess I could spell this right, you have to remember when we use this formula, A equals P times 1 plus R raised to T power, that's not the actual interest, even though that's what I called it. This is actually the new balance with compound interest, right? Because this takes the original amount and adds the interest already. So let's make this money here. But let's say we just wanted to know the interest. So let's give ourselves a new one here. So if we just want the interest, so what we would have to do is we'd have to say, instead of adding it like we did for our simple interest, we would take our new amount minus what we started with. Okay? So new amount minus the original, and that gives us $3,382. So now the difference between these, and we can actually do this too, difference between simple and compound, is it's just going to be equal to the compound interest minus the simple interest. So you should have got an answer that looked like $382.26. Another way we could have done this, since we have the new balances, we could have instead said, what is the difference between this balance and this balance? And we should get also $382.26. Okay, so that's that. So that's pretty neat. But this isn't I mean, it's not real. These aren't numbers that matter. So what I did, because I'm a nice person, I went and I looked up some actual rates you might get. And so this over here, Bankrate.com, and I took the highest rates I could find for a 5-year certificate deposit. Because really what we're talking about here, all this depends on you're putting in some amount of money just one time and you're just letting it sit there, which is what a certificate deposit is. Okay? So let's say you want to put some money aside for college. So you work over the summer and you make, I don't know, $2,000. And now the best rate we can get, and a couple different places offer this, is 2.25%, which is actually not that bad. Whoops. And then this should be a percent, so we're probably going to have to re-enter this. Okay, hold on. Oh, and the decimals are there, they're just not showing. There it is. Okay. And then let's say over time, let's say we want to have money for college. So you're in 8th grade now, so college is about 4 years away, so let's call that 4 years. Okay. And now instead of having to, let's make this a little bigger. Instead of having to work this all out again, all we have to do is highlight all these formulas we just came up with, and we're just going to drag them down one, and there we go. So if all we have is $2,000, if we invest it for 4 years at 2.5%, we'd only make $180 in simple interest or $186. And this one right here, this is more a realistic expectation. So you get $186. So after 4 years, you'd have $2,186 invested for college. So is that going to be enough for you? Probably not. So is $2,000 enough money in savings? No, not really. But now what if you went back in time to when you were first born, right? Put in $2,000 and we let it sit for 18 years. Let's see what would happen then. So we hit enter and, well, now we have almost $1,000 in interest, which is a little bit better. A little bit. So let's say we come back again. Let's say instead of $2,000, someone was super nice and left us $20,000. Let's see what that comes out to. Well, then we'd have almost $10,000 in extra money. So we can see how using technology, if we put in our formulas, then we can play with the numbers, and pretty quickly we can see how different factors affect the money we're saving. Okay, so that's pretty good. All right, then one more. I talked about the couple classes, the old episode of Futurama. So get your popcorn real quick. Get a quick clip here. I don't know if you can hear this.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Nifty pizza.
Okay, you had a balance of 92 cents.
All right.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $4.3 billion.
Surprise!
All right. So I always thought that was pretty funny. So let's see if that actually works, though. So it said he had 96 cents, which is this money, and look, he had the same rate we did, so 2.25%. Neat. Only he had it invested for 1,000 years. So let's see if TV cartoons do good math. Oh, it's too big to even show. Oh, did I? Hold on. Okay, I put the wrong number down. But let's see, like, how big of a difference this makes. So I put 96 cents, which was not right. It was actually supposed to be 93. So right now it's sitting at $4.4 billion. Okay. it was 93 cents. That comes out to 4.283 billion. So that would round off to 4.3 billion. So were they correct? Yes. And now the bigger point here that I really want to point out to you is what happens over time between simple and compound interest. With simple interest, all you would have ended up with after 1,000 years is $21. That's it. $21. Whereas with compound interest, it's over 4 billion. Okay? So the biggest benefit of compound interest is not the rate, it's not the principal, it's all about time. The longer you invest, the more compound interest becomes a very, very big deal. Okay? So that's it. Not too bad. Get your think through math done. Okay. Good night.